Guys, today's video is on solving absolute value equations as well as absolute value inequalities. Number one on the warm-up, if the absolute value of x is 7, the possible values of x are 7 and also -7. Absolute value makes the number inside positive. Whereas number two, if the absolute value of x is -4, what are the possible values of x? In this case, there is no solution. It is impossible to have a number take the absolute value of it and it equal a number that's negative. Just keep that in mind for our examples today. So the steps to solve absolute value equations. Number one, you want to isolate the absolute value expression. That means get the absolute value expression by itself on the one side of the equal sign and move the other numbers next to it away. You're then going to create two cases. You're going to set the number on the other side as positive and negative. You're going to have two different equations. You're going to solve both of those equations, and then you're going to check for any extraneous solutions. Extraneous means that you get the answer, but when you plug it back into the original equation, it doesn't really make sense. Let's look at number 3. Here, our absolute value equation is already isolated. So we're going to start out by setting up two different equations. Our original one, which is x minus 9 equals 5. We don't need the absolute value signs. The other equation is x minus 9 equals -5. We do the opposite of that one number next to the equal sign. Next, we'll solve our equation. Here on the left, we get x to be 14, and here on the right, we get x to be 4. So we have two answers, x equals 4, comma 14. Our last step is to check to make sure when we plug these numbers in, we get our original answer. I'm going to plug in 14 in for x first. 14 minus 9. And the absolute value, let's see if that equals 5. That is correct. And then I'm going to plug in 4 in for x to check to see if that also works. Absolute value of 4 minus 9, does that equal 5? 4 minus 9 is -5, and the absolute value of -5 does equal 5. So both answers checked out. We have two solutions here and no extraneous solutions. Let's look at number 6. In number 6, we need to isolate the absolute value expression first. We have to get rid of the 3 in front. In order to get rid of the 3, we're going to divide both sides by 3. Now we're left with the absolute value of m plus 8 equaling 13. Now that the absolute value expression is isolated, we can create two different equations, m plus 8 equals 13, and also m plus 8 equaling the opposite, which is -13. Our next step is to solve. Here we get m equals 5, and in the other equation, we get m equaling -21. Before we write that those are our two answers and we move on, we need to check for extraneous solutions. Again, we do that by plugging in the 5 and the -21 into our original equation. 3m plus 8 equals 39. And then we also have to check 3 times the absolute value of -21 plus 8. Does that equal 39? First case, that is correct. You get 39 over here and 39 here. In this case, -13, absolute value is 13 times 3. Yes, perfect. So we did not get any extraneous solutions. We have two solutions for this absolute value equation. Go on to the next page and talk about a more challenging example. Number 15, has multiple variables on both sides. It looks a little different than what we're used to. We're going to follow the same steps. Again, the first step is to get the absolute value expression by itself, the 8 minus 2n on the left, and I'm going to move over the negative 5n to the right. Now that the absolute value expression is isolated, I can create two equations. 8 minus 2n equals 6n plus 2. And the other equation is going to be 8 minus 2n. And you're going to do the opposite of both terms here to make negative 6n minus 2. Let's go ahead and solve this left equation. Here we get a fraction, n to equal 6 over 8, which simplifies to 3/4. And on the right, solving this equation, adding over the 6n, dividing both sides by 4, and then simplifying. Here we have two solutions. But remember, after you find a solution, you have to substitute and check to see if it is extraneous. For the sake of time, I checked my second solution of negative 5 over 2 by substituting negative 5 over 2 in for all three variables. And by doing that and simplifying using the order of operations, I found the left side ended up being 13 plus 25 over 2, which is definitely not equal to the right side of a negative 1/2. So my only solution is n equals 3/4. The video is very similar, except it's solving absolute value inequalities. So at the first case, here we have the absolute value of x is greater than 7. Think of it like an OR inequality when you have the greater than sign, meaning that you can have any number greater than or equal to 7 as an answer, or less than or equal to negative 7. Remember, when you were solving compound inequalities, you had the greater than sign. For the OR inequalities, they go different directions, whereas think of a less than sign, right, like this, being an AND inequality, compound inequality, where your solutions are connected, just like this. Here, the absolute value of x to be less than 4 are only numbers included between negative 4 and 4. The connected line, recall from compound inequalities for the AND. So, how does this apply to more complex absolute value inequalities? You're going to follow the same steps that you did with equations. You're going to isolate the absolute value symbol with the expression again. You're going to create two different cases. You're going to solve the inequality and then graph your solution in this case. Number 1. For this number 1, we're going to create our two absolute value inequalities. X plus 6 is greater than 7. And our second inequality is going to be x plus 6. We need to flip both parts here. Flip the sign to make less than, and also negate the other number to make it negative 7. So two things to do. Now it's simply solving. Here x is greater than 1. In the other inequality, x is less than negative 13. Now we just need to graph. We're going to graph x is greater than 1. That looks like this with an open circle pointed this way. X is less than negative 13. Open circle pointing that way. Interval notation, a little more complex. All the way on the left, it starts at negative infinity with a parenthesis. And then it stops at negative 13. And since it's an open circle, another parenthesis. And we're going to union, that means combine that with the other arrow here, which starts at 1 parenthesis and doesn't stop until infinity. That's your interval notation. Moving on to another example. Number 4 has a less than symbol. I'm going to make my 2 inequalities since it's already isolated. The absolute value symbol, is already isolated. Okay, what I need to do now is flip the less than sign, and then I also need to negate, take the opposite of that other number on this side. Solving now for n. And don't forget, when you divide by a negative, you flip the inequality symbol. Solving over here. Dividing by a negative again, I flip the inequality symbol. Here I'm going to be left with a fraction, which simplified is a positive 17 over 2. Now to graph, I'm going to start with greater than -5, greater than or equal to -5. That's a closed dot pointed this way. But then I also have less than or equal to 17 over 2, which is about 8.5. So I need to go closed circle at 8.5 and pointed less than. But since we're overlapping here, it's going to be a connected bar. So greater than or equals to -5, closed circle connected to 8.5 right here. That is your less than or and type of absolute value inequality. Interval notation, the lowest is -5 with a bracket because closed circle. The highest is 17 over 2, closed circle, so I need a bracket there. You can do some extra problems. We're going to do some more challenging problems in class, but write what general questions you have so far on solving these absolute value inequalities, and see everybody next time.